Okay, so this is the second method to solve the heat equation, that is implicit finite difference method, or we call it as the Nicolson method. Alright, so for the Nicolson method, the time is divided by 2. Okay, so that's why we can see this is k over 2, and also this one k over 2 at this is the time at j, and this is the time at j plus 1. So if we want to discretize, we are using the centered difference formula for both time and also for the space. For example, for the time, we are using this formula, uij plus 1 minus uij, and then divide by 2k. By using the centered finite difference, 2k, but this time, our k is divided by 2, so we have our k now k over 2. K over 2. So this is the formula, or the discretization formula for the time. And for the space, so we just take the average. We just take the average for the uxx. So don't forget the 1 over 2. And by using the centered difference for the time j plus 1, and also for the time j, so we have this formula. So this one j plus 1, this one should be j plus 1, this is typo, j plus 1 and also j plus 1. So by using the centered finite difference for the x, so I minus 1, I plus 1. Okay, so for the j, this is for time j. Okay, and then by using the centered finite difference for x, so I minus 1, ui plus 1 over h squared. Okay, so by using that formula, centered formula, so we have this equation, and then rearrange. So this will be the formula that we are going to use to solve this heat equation by using the implicit finite difference method. Okay, so this will be the targeted cell lah. Okay, the one that we want to find the answer. Okay, uij plus 1. Alright, so for example, so this is the example, but I'm using the previous, we have when we done for the explicit finite difference. So similar questions, but now we want to solve by using the implicit finite difference method. Alright, okay. So the question C, by using the Nicolson method, show that the above problem can be written as below. Okay. So the question number 1. So this now we have ut equal to 0.01 uxx. Okay, so by using the centered formula for time, so we have ui j plus 1 minus uij over 2, but time is divided by 2, equal to, so half, and then by using the centered difference for the j plus 1, so u over h squared, and also apply the finite difference, centered difference for the time j. So we have ui plus 1j squared. Alright, okay, and then k we move to the right hand side, but 2 we move to the left hand side. So now we have 2 so let's say I just put r, where our R is equal to 0.01k over h squared. Alright. Okay, now we rearrange. So the one with the j plus 1, we move to the left hand side and j to the right hand side. So we will have one. Okay, and then move all the j to the right hand side. So we have all this j. Okay, so equal to positive but negative 2 G. Okay, so this will be the discretization formula. So let me check again. I plus 1, j plus 1 negative, I j plus 1, 2r plus 2, okay. I minus 1, j plus 1, negative r, okay. I plus 1 r, 2r minus 2, I minus 1 j r, okay. So r is equal to 0.01 k over h squared, okay. So this is the answer for C. So this is the answer for C. Okay, now D. By using the equation in part C, write the solution until t equal to 0.5 in A equal to B, then solve the linear system by using the Gauss-Seidel method. Alright. Okay. So since this method is related to the previous, so I just take the one that we sketched before. This one. Right. So the question asks to find the solution at t equal to 0.5. So our target is we want to find, so this is t equal to 0.5. So our target is we want to find the solution at u equal to 1, 1, 2, 1, 3, 1 and also 4, 1. Okay. So this will be the target, the point that we need to solve, or we need to find the solution, right? Okay, alright. So now, just now our R is equal to 0.01k. What is our k? K is equal to 0.5 over h squared. So equal to 0.0313. Right, okay. Now, if we want to find the point or the value at u11, so look at the discretization formula. So we should start with I is equal to 1 and j is equal to 0. So R is equal to negative 0.0313. 2 plus 2r is 0.0313. 8374. Right, okay. Negative will be positive. Zero. Okay. So where do we have the value? So we have to substitute. So we have the value at 0, 1, and we have the value at 2, 0, 1, 0, 40, and also at 0, 0. So the answer will be 80. So this is your first equation. Alright. So please remember, if you need to find 4 points, so you need 4 equations. So you have to continue. For I is equal to 2 and j equal to 0. So when we have the answer or the point, the solution, we have to substitute. As your second equation, and then continue. Okay, and then last equations, so pi equal to 4 and g equal to 0. Okay, so we have the value at 5, 1. And then 5, 0. Right? Okay, so this is 4 equations. If we want to find u11 until u41, and then the questions asks to put your matrix in matrix form and then solve by using the Gauss saddle. So you have this matrix, so you just put in the matrix form lah. Okay, but since we want to start with the U11, okay. So the first equation, and then the second equation, so we have U11 negative 0.03. And for the third equation, so we have negative, negative, positive, negative. And then the last equation, question number 4, we have 3, 1 and also 4, 1. So 0, 0. Right, so this is your answer in matrix form. and then you need to find lah by using the Gauss saddle. Okay, later you try what we have learned in chapter 2. You apply what we learned in chapter 2. But your answer will be, actually during your exam kan, you can check your answer by using your calculator tau. After you get the answer, you can check your answer by using your calculator. So this is your answer. Alright, but guys, for this exercise, you need to apply Gauss saddle, okay, in your exam. Alright, okay, that's all.